Welcome back, my wonderful student. In this section, I'm going to talk about Boolean. As a software engineer, I realized that Booleans are very important in programming language. Booleans represent one of two values. So it is either true or false. Supposing we have print equal to 5 is greater than 3. In this case, we expect to see true, which is true. So let's have 10 is less than 3, which is false. What about print equal to 10 is equal 9? False, which is true. I want to use an if statement here to demonstrate an example to you. Don't worry about if statement here. When we get to looping, I will fully explain how it works. For now, just know that to construct an if statement, you begin with if followed by the expression. Supposing we have A is equal to 300 and B is equal to 44. So to construct an if statement, if you begin with the keyword if B is greater than A, and if B is greater than A, I want you to print. Let's use F string here. Let's print B. B is greater than A. S. Print B is not greater than A. What do you expect we'll see? 44 is not greater than 300, which is true, because B is less than 300 in this case. To evaluate variables, the Boolean function allow you to evaluate any value and give you true or false in return. Supposing we have test is equal to IPython. There should be a string. This should be a string. IPython. So let's see if it has a value in it. So to evaluate it, what are we going to do is we need to use the bool function. So print bool, we pass in the name of the variable that wants to check, which is true. That of number as well. Suppose we have number equal to 17, and print number, which is true. Perfect. Python operators. The beautiful part about operators are they are used to perform operation of variables and values. In Python, we have the arithmetic operator. So 3, the addition, 4 plus 1 is 5. 4 subtracted by 1 is 3, and then 4 multiplied by 4, we have 16. 4 divided by 2, we have 2, which is true. We also have the modulus as well. To implement modulus, you use the percentage symbol. By 2, we have 0, which is true because it returns the remainder. Modulus always returns the remainder. 5 modulus 2, in this case it will return the remainder of 1. Perfect. So we have the exponentiation as well. Yes, we have to implement it. Use the star twice. Exponent. Let's say we want to raise it up to. We know exponential is whatever value we have at our left hand side will be raised to the power of. So let's say we want to 2 raised to power 5. In this case, this is how you implement it. So we have 32, which is perfect. 2 times 2 times 2 times 2. That's how you. So basically, we have 2 times 2 times 2 times 2 into 5 places. And we also have the floor division. To implement the floor division is very easy. Let's say we have s is equal to 15 in this case, and y is equal to 2 in this case. So to implement the floor operation, let's print the value. I print s. We use this division sign / twice y. So basically, we are saying what will be the value of s, the floor division by y. We have 7, which is very perfect, which is true. So the floor division rounds the result down to the nearest whole number, and that is what it does there. So we have the arithmetic operators as well. So arithmetic operator, there's something I want you to pay attention here, because this is very important. It's a shorthand. I want to use a shorthand, the arithmetic operator. So let's say we have s is s plus equal to. Now, by the way, let me quickly assign s is equal to 9 here. So, and we have s in this case, which is 9 plus equal to 3. What do you think would be the answer? So basically what is happening here is we have, let me quickly add a comment here. We have s is equal to s plus 3. What do you think would be the answer? So we know s is 9 and we have 3 here. So 9, 10, 11, 12. We're expecting to see, if we check the value of s in this case, we're expecting to see 12. Perfect. The same thing apply with that of the subtraction as well. S equal to 9. Let me quickly just assign that. So s subtracted equal to 3. So what would be the value of s in this case? 6. Perfect. The same thing apply with our of multiplication and division as well. So to do multiplication, let's say we have s is equal to 2 in this case. S multiply equal to 3. So basically we're saying we have 2 times 3. So in this case, what would be the answer? We have 6. Perfect. The same thing happen. The same thing works as well. Division. So let's say we have 9, and we have s divided by, which is equal to, divided by, and we have the equal to sign by 3. So what would be the value of s? We are expecting to see 3. Perfect. So we also have the comparison operator as well. The comparison operator work the same, almost similarly. It works similarly. So let's say we have s is equal to 3 and y equal to 3. So in this case, s equal to y. What do you expect to see? True, which is perfect. And we also have the not equal to as well. So to implement the not equal to, s is not equal to y. This will result to false. We also have the greater than as well. So let's say we have s is equal to 3 and y equal to 2. So is s greater than y? which is true, is s less than y, this will result to false. And also we have the greater than or equal to as well. So s equal to 4 and y equal to 5. So let's see, is s greater than or equal to y, which is false. But is y greater than or equal to s? This will result to true. No, we have syntax error. Is y equal to greater than or equal to, which is true. Perfect. We also have the less than or equal to as well. The same apply. So logical operator. To combine conditional statement, we use logical operator. So supposing we have s equal to 4. So now let's check something. S is less than 5. This is true. Which is true because s is 4. So 4 is less than 5. And s, which is 4, is less than 10. This will result to true. Which is true. Both statements are true. So let's say we have s equal to 3. And s is less than 5. Which is true here. Or this is the or. This is the or logical operator. Or s is less than 4. Which is true as well. So we also have the not logical operator. So let's say we have s equal to 5 in this case, and print not. So basically what we are actually doing, we are actually revising the result. So s, which is 5, is greater than 3, which is true. And s, which is 5, is less than 10, which is true. So what are we doing here? We are using the not to reverse. We are using the not to reverse the result. So what will be our output here? Let's see. Which is false. So this ends this section. See you in the next section, and bye.